Well, hello there, students. This is Mr. Krause. I'm ready to rock and roll, rolling, rocking with the logarithms. Everybody loves logarithms. Look how many pages of work this is. It's like, oh my God, we're going to be here for like an hour of fun with logarithms. Can you think of anything else you'd rather be doing? Seriously. I'm thinking, go to the movies. Nope, logarithms much better. Go watch the Stanley Cup playoff. Nope, I can be up there doing that right now. I'd rather be doing logarithms with you. Wait. I got to figure out how to get TV on my computer so I can watch the game. I can't watch the game. Oh, man, this is awful. All right, I got to hurry up and get these logarithms done. This is this is broken down number 8. By the way, if you want to know where these things can be found, if you haven't been watching all the other videos, you go to my website. It's very easy to remember. It's mrkrausemath.com. Blow up your screen if you can't see that. It's pretty easy. It's MRKRAUSE math.com, all one word. Go over here. Oh, let me refresh that because I actually have this updated. So when you click on Regents Review now, you'll see Algebra 2 topics, question, or that's me rewinding what I just said. Algebra 2 Trig Regents questions by topic. Oh my God, it's so awesome. So right now I said video coming shortly. I'm working on logarithms right now. But what I have done already is don't have trigonometry. That's going to be a long one. I'll probably do that tomorrow night. I have statistics done, I have regression done, I have solving systems of equations, solving radical equations, and probability and inequalities. I'm uploading factoring as we speak. Well, actually, I'm about to do it. And then I'll do logarithms, stats, and then what was the other one? Oh, miscellaneous. That's all the other weird stuff that's going on there. So we got 2 more after this one. But let's get number 8 done. By the way, if you don't have my flashcards yet, please get my flashcards. How can I stress that enough to you all? Right here, click on directions how to get my flashcards. Go over here to Study Blue. Study Blue is free app for your iPhone, iPad, probably Windows 2. Also for the computer. Let me just go through a few of these. And then we stop. Look. Oh, you don't know that. I don't like that question. Okay. What if you saw this? Would you know how to do this problem? Like if you saw when does secant x equal cosecant x, or whatever the problem was, what do you know about those two x and y? What do you know about that thing and that thing? Do you know that, oh, they add up to 1 or add up to 90 degrees? Did you know that? Did you know that? I don't know if you knew that. I knew it. That's silly. Do you know what x to the negative 2 is? If you don't know what x to the negative 2 is, we got some serious problems. You ought to know what x to the negative 2 is. It makes negative exponents have nothing to do with mean negative. They make fractions. So this is really 1 over x squared. You guys got to know this stuff. You don't really need to know. That one you can do in your calculator. What point do all logarithmic graphs go through when they have no transformation? So just log, no modifying shifts left or right or up and down. They all go through the point 1, 0. That's on the x-axis. By the way, all exponential functions go to the point 0, 1 because they are inverses. What's the center of this circle? It's 5, negative 2. Did you know the radius was 3? I did. But anyway, these are free. What you do, oops. Let's go. How do we get done? Done, back. Maybe we'll go back. Back. Yes, leave this page. Okay, let's do that. Oh, yes, leave this page. We'll do this again. Get my flashcards. Go to Study Blue. I want to show you, the directions are pretty simple, but what you'll do is you want to make sure that you get because some people have been messing with my flashcards. Make sure when you go in here, you're clicking on new. You got new algebra. It should be 244 cards. All right, that's enough of that. Let's get going. Rock and roll, rollin' rocka. I'm so excited. It's 9 o'clock. I just got home from work because we had our awards night, which I didn't get the awards, but I'm not really supposed to get some awards, although I'd like some. Let's see. I hope my calculator works because today is the last day I'm legally probably allowed to use it. I'm going to have to start showing you a camera of my freaking thing sometime. All right. So we're going to just start with this problem right here. Now, since these are all numbers, I'm just going to see if this kind of works out. I think it does. I think if I just put in log base 8 of 16 in my calculator, I think it's going to give me a nice number. I don't like that one. Why does it give me a decimal? Control. Well, what I can do is go menu, and then number, and then approximate the decimal. Or approximate the fraction. It'll give it to me. Jeez. I don't know why it's having such a hard time with this. Why is it doing that? It shouldn't be doing that, kids. Let's go to 5. Document settings. Float normal. Okay, whatever. Auto calculation mode. That should be right. All right, well, what it should come up as 4/3. It may not. I'm going to show you another way to do this problem anyway, but it'll come up as 4/3. It should come up as 4/3. It probably does in your calculator. X plus 1, we subtract 1, and we get 1/3. If we do it in our calculator, we get 1/3 is equal to X. Now, if you took your calculator, even if you go back to your calculator and you subtract 1, you should know, oh my gosh, go up to this crazy thing up here and subtract 1, you should know that 0.3 repeating is 1/3. And it said the exact value, so you have to give it 1/3. But here's another way to do the problem. We can do it as a change of base. We're going to change this thing. Now, if you solve a logarithmic question, in order to solve it, you must use an exponential function. If you have an exponential function, in order to solve it, you must use a log function. They go hand in hand. They are inverses of each other. To solve one, you must use the other. To solve a square root function, you have to square it. They're inverses. To solve a cube root function, you cube it. So this is a log function. I'm going to turn it into an exponential. And I know you want to hear this. It's all about that base, all about, oh my gosh. This is what happens when you go to bed at 1 o'clock in the morning, get up at 5 o'clock in the morning, and have no rest during the day. And you just get home from work. So it is all about that base. So we're going to write down that base. There's the base right there, 8. Now, right now, currently, it looks like 16 is my exponent. The 16 and this side are going to switch. So 8 to the x plus 1 is equal to 16. Now what I'm going to do is, wait a second. What I got to do here is I got to make 8 and 16 look a lot alike. So 8 is the same as 2 cubed, but we still have the x plus 1 there. 16 is the same as 2 to the 4th. Therefore, I'm going to set the exponents equal to each other. So that's 3x plus 3 equals 4. Okay, I'll just solve it. Bring the 3 over. I get 3x equals 1, or x equals 1/3. Done, bodied, over and out. Roger than that. All right, let me see how long I've been jammering for already. Oh my gosh, I'll be right back. I'm back. Every time I wave, like you see the green screen go crazy behind me, I think. Anyway, I'm back and I'm ready to go. So let's take a look at this one. Now, much like we did this problem up here the second way, when the bases are the same, we're going to do that same thing over here. I need a new color. So what we're going to do is the right side, by the way, anytime you have these bases and you look like maybe I can make them the same, try that. It's pretty easy. So what we're going to do is we're going to leave this as 2 to the 3x minus 1. No problem. We're going to do that. But I got to change 16. I don't know much about 1/16, but I know 16th is, I just wrote down 16, is really, and I just did it a few seconds ago, is 2 to the 4th power. But since it's a fraction, and if you remember a couple of minutes ago, I said, what is x to the negative 2? Kind of prophetic. It really makes it x to the positive 2. So if I was going backwards, it would make this, right? Remember, negative exponents make fractions. So when I come over here and I say, hey, 2 to the 4th is 16, but 2 to the negative 4 is 1/16. Oh, okay. Now I just set the exponents equal to each other. So I go, okay. Negative 4 is equal to 3x minus 1. Bring over the 1, you add 1. You get negative 3 is equal to 3x. That's some sick writing right there. And you get x equals negative 1. By the way, all of these problems should be checked. All of these problems should be checked. You come over to your calculator, you say, okay, I'm going to take negative 1. I'm going to stow it into x. And by the way, you can do this on the 84 button. Down here, over here, they got a button called stow. Down here, there's a simple stow button. Use that X button that's up there. And then you type in the left side, or the right side, 2 raised to the 3x minus 1. 3x minus 1. Enter. 1/16th, 1/16th. Yay! All right, so these problems here look like they have similar bases, 5 and 125. Now, 5 you can't do it. By the way, if you're ever going to change a base, change them down to 2, 3, or 5. There's very seldom chance you might use 7, but generally you're going to use 2, 3, or 5. If it's got a 5 in it, it's going to be 5. So we're going to do 5 to the 4x is equal to, now we're going to modify this. We're going to change this to 5. Let's see, 5 times 5 is 25 times 5 is 125. So this is 5 cubed, but I already had an x minus 1, so that has to stick around. Now that the bases are the same, all I got to do is come through and set the exponents equal to each other. Oh, it's so color-coded. It's so much festive and fun. Did I just say that out loud? I can't be a bald-headed mean guy and say that stuff out loud. 3x minus 1. We get 4x equals 3x minus 3. Bring this over and you get x equals negative 3. Can't be. Ooh, you got a poet. Didn't even know it. Let's check it out. Negative 3, control var x. Somebody time me. See how long this takes. Go 5 to the 4x. 5 raised to the 4x. Ka-ching. Weird answer. Let's check the other side. 125 raised to the x minus 1. X minus 1. I hope I get the same weird answer. Oh my gosh, there it is. Now, who thought it was 1 over 24,414,000? No, that's 244 million. That's what I made last year. Why am I doing these videos if I'm making $244 million a year? What am I, crazy? By the way, hit the like button, hit the subscribe button. There's a donate button there somewhere if you'd like to hit the donate button. You know, I could use like a new haircut, toupee. Take my head. Let me see if I can put some hair on my head right over here. Woo, look at that. Mr. Krause got a hairy head, little mustache. Anyway, here we go. It's a log question. In order to solve a log question, you have to turn it into an exponential function. And it's all about that base. All about that base. So my base in this case is x plus 1. I know this is a really annoying video. Some of you are like, oh, I'm too manly for that crap. I'm sorry, man. I'm just really tired, actually. So right now it looks like 64 is my exponent. We're going to switch these up, changing the base here. We're going to go x plus 1 cubed is equal to 64. Now, I actually had kids this year decide that they were just going to write out x plus 1 times x plus 1 times x plus 1. There's somebody that did that already. It's like, oh my God, I just did that. And that's really hard. I get x squared plus 2x plus 1 times x plus 1. And then they're going to get this really long thing. And then they're like, what the hell do I do with this? No. In order to get rid of a cube, we just take the cube root. What? It's that easy? Yeah, you just take the cube root and you get x plus 1 is equal to 4, or x is equal to 3. Yeah, it's that easy. It's a 2-point question. Guys, you have to know where you are in the test. If it's a 2-point question, you're not doing this crazy crap right here. No way. It's easy. 2-point questions should be done in like 30 seconds. If you know what you're doing, they should be done in 30 seconds. Okay. Now, how many of you, when you look at this problem, go, what the is that E thing? I'm afraid of the E thing. The E thing is a little scary. I'm not going to lie. It's just exponential. It's an exponential function. It's a base. Now, it happens to be the base E. And in order to solve ones that have a base E, you need to use logarithms. Now, if you come over to your calculator and you look at this E button, you see this is e to the x, and above it says ln. They're inverses of each other. Just like any exponential function, 10 to the x is it's exponential. It's inverses logs. So when I go to solve an E function that has an E, I know I have to do a change of base. Now, what we're going to do is we're going to change it. So instead of having an E, we're going to change this to a log function, but I have to use natural logs. So I'm going to use natural log. It's all about that base. Now the base goes down here. So the E goes down here, and then these two things switch sides. Sound familiar? It's going to come up a few times. So natural log of 12 equals 4x. Now I just divide by 4, and I am done. Well, I actually have to put this in my calculator. So now one of the things you're going to notice, if you come over here for natural log and you click on natural log, okay, and you click on natural log, there's no place for the base. And that's because the only base you can use with natural log is e. So they say if you don't have to put it in, why bother? You can't use any other base with e. So there's no reason to put it in. So I just take the natural log of 12, I hit enter, and I divide by 4, and I get 0.62122. X equals 0.62122, rounded to the nearest hundredth. X equals 0.62. Ka-chang. By the way, if you're just watching me like a trained monkey do these problems, I just have one thing for you to say to you right now. Sign up for summer school. Yeah, because you're going to need summer school. I'll be back with a better attitude. I'm back. I'm happy. Seriously. Push the pause button. Try the effing, that means fun or fraction, problem on your own, and then come back. Oh, hey, you're back. Oh my God, it's so much fun. I felt like we weren't gone at all forever. It was like 2 seconds for me. Anyway, here's a log function. We're going to turn it into an exponential function. So it's all about the base. So the base is 5x minus 1. Since it's the binomial, I'm going to keep it in parentheses. And then these two things switch sides. So 5x plus minus 1 to the 1/3 power equals 4. Now, for those of you that have no clue what a fraction exponent does, I was swearing. I was saying things like fraction and fun. If you don't know what a fractional exponent is, we got problems. One of my flashcards says, what does this equal? And you got to know that's equal to the cube root of x squared. But you should also know that x to the 1/2 is equal to the square root of x. X to the 1/3 is the same as the cube root of x. Remember, a fractional exponent means you're going to have a root. Now, I'm going to show you two ways to solve this problem. One, I'm going to rewrite this as really what it really is. It's really just the cube root of 5x minus 1 equals 4. Now, if I wrote it like that, most of you would say, oh, I got it. You just cube this side, and you just cube this side. Yeah, you'd be right. 5x minus 1 is equal to 64. Bring the 1 over, 5x is equal to 65, and then x is equal to 13. Absolutely, that's how you do that problem. But if we go back to this problem right here, and I say, okay, another way to do that, if any time, because this is going to come out, this is going to be like, I'm being prophetic again, because this is going to come up in a problem later on. Anytime you have something raised to a fractional exponent, if you raise it to that side to the reciprocal, which is 3 over 1, what happens when we have an exponent raised to an exponent? Remember, we multiply the two exponents, so this ends up being just 1. So 1 as an exponent is nothing. I don't need it. 5x minus 1 equals, but if I cube this side, because that's really just a cube, I got to cube this side, and I get 64, and then we're back to this problem here. All right, that's it, and it works, so I don't have to check it. All right, here we go. It's all about that base, about that base. By the way, here's what I want you to do. If there's a log question on the day of your Regents exam, and you see it, and you know how to do that problem, and in your head, you can't get that ridiculous song was sung by whoever ridiculously sang it, I want you to go like this. Okay, that was some serious white boy action right there. There was like no rhythm whatsoever, but I'd like you to come up and get the action going. In the middle of the test, man, and the people around you are going to be like, what the hell's wrong with him? But there'll be 1 or 2 kids in that room probably that watch that same video like, yeah, he's got his groove on. What about that bass? Holy crap. This video is going to take forever because I won't shut up. You should just fast forward. Every time I start acting stupid, just fast forward. I apologize. So it's all about that base, 27. We're going to switch sides. I'm trying to make this something you can remember. All right, 27 to the 4/3 is equal to 2x minus 1. Now this you can just type into your calculator or you can use your brain. The answer is 81. But if you typed in your calculator, it'd be 81. I'm trying to save time because I don't want to waste your time. Is equal to 2x minus 1. Bring the 1 over. I get 2x is equal to 82, or x is equal to 42. I'm going to check it because it seems kind of stupid. So 42, let's see how long it takes. 42, control var x, bring x equals, and then we go log base 27, control log 27 of 2x minus 1. 2x minus 1 equals, whoa. Oh, first of all, this should be 41, not 42. Brain farts. Oh my God. You know what's really cool? I was just going to keep going and not even bother to check that. I don't even know why I decided to check that, but man, am I glad I did, because that was totally wrong. 41, control var x. I hope this one works out a little bit better. I don't have to retype that line. Just go up here, click it. There it is, 1.33333. And if you don't know what 4/3 is, you can just do 4 divided by 3, and it'll tell you 1.3333333. So there you go. Check. All right, so here we go. Again, this is a 2-point question. I know. It's a reading problem. You're like, oh my God, the number of bacteria present in a petri dish can be modeled by this. Holy shnikes, what the hell is that thing? Where n is the number of bacteria present in the petri dish after t hours. Assuming this model is to determine the number of hundredths, the number of n to reach. So, okay, so first of all, they're going to tell us that n is this. So, we're going to replace that in for n. 30,700 is equal to 50 e to the 3t. So those of you that don't have me as a teacher, I'm going to tell you right now. One of the things I want to make sure you understand is anytime you got a weird, funky looking thing in your problem, isolate it. I don't care if it's an absolute value. I don't care if it's a logarithm. I don't care if it's an exponential. I don't care if it's radical. Absolute values, I don't think I said that already. Get the weird thing alone. In this case, the weird thing, besides the guy teaching you, is this. That thing's weird. I don't know what it is. It's that damn E again. Ooh, sorry, parent. Didn't mean to swear. Turn me off. Anyway, so we're going to get that alone by dividing by 50. And if you put in your calculator 30,700 divided by 50, not going to look down my notes, 614. Yes. So 614 is equal to E to the 3t. In order to solve an exponential, you have to turn it into a log. Exponentials are just the special case. You have to turn it into the natural log. It's all, yeah, getting the groove on, yeah. By the way, before I continue, public service announcement. This test is at 8 o'clock on June 17th, 2016. At 8 o'clock, this test is going to begin. At 10 o'clock is the earliest you can possibly leave this test. Now, here's what I want you to do. You take your pen. I know it doesn't look like my fancy pen, but you take your pen. You put your pen down. It's time for a break. You see it, they see up in the lights, 10 o'clock, right? And you're like, summer's coming. So what I want you to do is put your pen down. I want you to sit back in your chair. If you brought yourself a little water, pick up your water, take a sip. I want you to sit back. I want you to relax. Just sit back and relax. I don't care if you're in the hardest problem ever. Just sit back and relax. Go like this. And look around. Don't look too much because I don't want you to think you're cheating. Just look around a little bit. Take a look. All the kids that just got up and left, you know where they're going? They're going to the counseling office to sign up for summer school. The rest of you kids sit back, work. Stay the whole time. Stay as long as you can to 3 hours. Just look that test over. Check every problem. Stow everything you can stow. And check it. Because the kids leaving are the ones seriously that are not going to do well. Okay, and a public service announcement. We're going to take an exponential function. We're going to turn it into a natural logarithm. So natural log, it's all about that base E. And then these two things switch sides. So of 614 equals 3t. Divide by 3. What the hell? Divide this side by 3 and divide this side by 3. So we come over to our calculator. We say, okay, natural log. Again, it's not going to let us put the E in because you can only do the natural log with E. And then divided by 3. And I get 2.13999. So 2.13999 rounded to the nearest hundredth. By the way, rounding is such a pain on this test. Be careful with the rounding, please. Problem number 8. Bodied. All right, moving on. Oh my God! There's like 2 paragraphs. You can't have 2 paragraphs in a 2-point question. It's not possible. Whoa. Guess my hand didn't like that problem either. All right. All right, so what we're going to do is we're going to read this slowly, but I'll be right back. I'm back. Okay, here we go. Okay. So a formula for, see, there's a lot of wording going on here, and really all part 2 questions are sub some stuff in. Let's see it. We'll see if it works. So we're going to use this thing, this formula right here. A equals PERT. Principal exponential function R to the T. Where A is the amount of money in the account, P is the initial investment, the amount of money you put in, R is the interest rate, and I'm going to star that one. I'll come back to you'll see why, and T is in years. Okay, so using the formula to determine the nearest dollar amount, the amount after 8 years if $750 is invested. Now, the reason I asterisk this interest rate is because this is the most commonly missed thing. You're going to do A equals P, my initial investment, E to the RT. Now, T is easy. It's just 8. But 3%, I can't tell you how many kids are going to put 0.3 in there. You got to remember, if the number is less than 10, which it almost always is, it's going to be 0.03. Right? I don't care if it was 3.5%, that means it's 0.035. If it's 8.1%, that means it's 0.081%. Anything less than 10, it's going to be 0.0 something. Okay, be careful with that. Now all I got to do is type it in. Type this puppy in. Gotta get rid of that. Type this puppy in. 750 E. See, I just clicked the E button. E to the 0.03 times 8, and I get $953.43. A equals 953.43. I should get the next number, 6. What are we rounding to? The nearest dollar. Okay, 953 bucks. Woo! There she goes. There it is. Yeah! All right, here we go. So on these axes, I need to graph this thing. All right, so the easiest way to handle this is just put this sucker in your calculator, show a table of values, and plot the sucker, and don't look stupid. Don't go like this, by the way. I think it looks like that. So, you know, I always love the kid that does this. Actually, what I mean by love is, like, I want to strangle them. I really don't, because that would lose my job, and I wouldn't be able to make videos. You'd be like, oh, hey, did you see the video of the guy strangling the kid? Oh, that was fun. It was on, like, what's that? North Star, Rockstar, whatever the heck it's called, where you show all the fights. Go, stupid people. So anyway, let's see what we got here. 2 to the x plus 1. So we're going to graph 2 raised to the x plus 1. Get out of exponent mode. Oops. Sorry, I got out of exponent mode too early. And I forgot the plus, minus 3. So I see a kid, it goes like this. Oh, look, it goes to that point. So I'll put a point there, and it goes like this and something like that. Oh, my God, that graph is great. You're an idiot. Seriously. If you see one of your friends do this on the way out, punch them in the head. Just rock and sock and punch them in the head. You go to your table, Control T, and you go all the points that you can get that are kind of nice. 2.5 is nice. 2.7. This is that's like almost -3. So let's start with that one. -4, -2.85. Ooh, 8. We'll go 8/8. -3, -2.75. -2 is -2.5. -1 is -2. 0 is -1. 1 is 1. 2 is 5. And 3 is 13, which you're not really going to be able to put in the graph. So let's get all the ones we can get in. 0, -1. 1, -2. 1, 1. 2, 5. 2, 3, 4, 5. And then 313 would be somewhere up here, but you can't really grab it. So we'll try to do our very best. Now, it's very difficult for me to do this. Do your very best. Do your graphs in pencil. So next, -2, -2.5, that'll go in the middle. And the next two, get off my screen, next two are going to go like a little bit closer and a little bit closer. And it looks like we're just going to do this. Just put a little, oh wait, it says graph from -2 to +2. So I got to graph from -2 to +2. Oh, I almost screwed this up. So that means you can only graph from -2 to +2. That means they only want to see this. I almost screwed that up. I did screw it up on my notes. There it is. That's what you got to graph right there. Because it's telling you that you can only graph here. So it would look something like that. Hopefully yours is a little neater than that. All right, here we go. You should try this on your own. I'll wait. No, really. I'll wait. No, really. Hit the damn pause button and I'm going to wait. Oh, hey, you're back. That was fun. Anyway, we're going to change 16. We're going to change it into a 2. 2 to the 4th, but we already had it. Well, that's no good. All right, I think we're back. 2 to the 4th is 16, but we already had a 2x plus 3 up there. 64 is 2, 4, 8, 16, 32, 64. Now, if you're not certain of that, just come over here, hit your calculator and go 2 raised to the 5th. Oh, that's 32. So 2 raised to the 6th is 64. So 2 raised to the 6th, x plus 2. Well, now that the bases are the same, you know, this block here has to be the same as this block here because it's 2 to the block is equal to 2 to the block. So all I got to do is set those things equal to each other. I'm going to skip steps. 8x plus 12. You're probably going, oh, you just distributed. Or some of you are going, what did you just do? Distribute, distribute. And on this side, I get 6x plus 12. So let's see. I bring the 12 over. And I get 0. I get nothing. And I bring the 6x over. I get 2x equals 0. So x has to be equal to 0? That's really weird. X is 0? Make your answer look fancy like that. And then I would go check this sucker. We're going to do 0, control x, or control bar x. 16 to the 2x plus 3. Go back to the original. 16 raised to the 2x plus 3. Hit enter. 4096. And 64 raised to the x plus 2. Oh. 4096. There's our answer. Wow. Didn't suspect that. Yes, I did. I knew the answer ahead of time. Oh, my goodness. We're at the 4-point questions. Now, once you get to the 4-point questions, not only are you going to have to do something that you did in the 2-point question, like changing the base, but then you're probably going to have to do some factoring or some quadratic formula or something like that. Probably not for the 4-point question. You probably won't have to do the quadratic formula, but you will eventually probably. So let's see how much time I'm on. I'll be back. It's like magic. I disappeared. Now I'm back again. Oh my God. Who needs sleep? This guy. All right. So here we go. We're going to start with the 4-point question. So we have a logarithmic function. In order to solve a logarithmic function, you have to convert it into an exponential. It's inverse function. We're going to use its inverse to solve it. So you know what I'm going to do? It's all about that. Remember, if you get that logarithmic question, the log question, I expect the whole gym to be going like this. In practice going, what the hell's wrong with those kids? Why are they all doing that weird stuff? Man. All right. I don't think I've ever made a weird video that's this long because I'm this annoying. But anyway, here we go. No comments. I don't want any comments about how annoying I am. All right. It's like past my bedtime. It's almost 10 o'clock. Anyway, we're going to do x plus 4. That's our base. Here's our base. Now, these two things, just like before, I don't care how complicated they are, they're going to switch sides, is equal to 17x minus 4. All right, so on this side, we got to double distribute. So we're going to do x plus 2 times x plus 2 equals 17x minus 4. Now, those of you that try this and put down here x squared plus 4, take your right hand, open it up, and slap yourself in the face because you deserve it. Ow. Anyway, double distribute this, you get x squared plus 4x plus 4 equals 17x minus 4. All right. Now we're ready to rock and roll. It's just a quadratic, no problem. If your x squared's over here and it's positive, which it is, we're going to bring the other stuff over. So minus 17x plus 4. I don't remember doing this problem. Oh my goodness. I'm so embarrassed. I wrote this down wrong. How embarrassing is that? Let me catch up. This should be, I was going to say, I don't remember these numbers. And it didn't look like it was going to factor. X plus 4. I can read ahead on a problem, so I'm like, that's not going to factor. Okay, x plus 4 times x plus 4. So we get x squared plus 8x plus 16. All right, much better. So we're going to subtract 17x, and we're going to add 4. So I end up with x squared minus 9x plus 20 equals 0. We now have to factor. Factoring is not too bad. They multiply to 20, add up to negative 9, so they both have to be negative. And negative 4 and 5. So my two answers are x equals 4 and x equals 5. Later on, I'll check a problem that doesn't work, but you absolutely must check these. Now, the reason you want to check these, now wait, let's see how long this is going to take me. I wish I had a timer up here. Maybe I can do this. I'll put this recording, this is my recording timer. I'll put my recording timer up there, and we'll start it right at 3 minutes. Okay, we're going to do 4, control var x, enter. The problem is log x plus 4, control log, oops, escape. I'm even making mistakes. Control log x plus 4 of 17x minus 4. Does that equal, it equals 2. So that one's done. Now I just do 5, control var x, enter. Hit the up arrow button. You don't want to retype that line in there. 2, boom, 37 seconds. And I made mistakes. I checked them both. They both work. All right, kids. This one's rough. I'll get rid of my timer. This one's rough. Not going to lie. So here's a problem, and I want to go through this one. Like, look at this problem. I really want you to pause this one. Try it on your own. I'll tell you the number is a multiple of 100, and it's less than 1,000. I hope you paused it and you're back. If you didn't, pause it now. Try it on your own. Okay. Now you're probably back with some frustration. And I agree. If you learned something from a little earlier, you probably rocked this problem. If you didn't, you got a problem. So let's go take care of it. We're going to take care of this piece first, right here. This is a log. We're going to turn it into an exponential. You know it's all about that base. In this case, the base is 4. And then these two things switch sides. So 4 to the 2.5 equals x. Now, if you put that in your calculator, you end up with x equals 32. You can trust me on it, or you can try it. I don't really care. Over here is where you're, and probably if you did it, you probably got that part right. But here's where you're going to have your problem. It's all about that base. So we're going to do y to the negative 3 over 2 equals 125. And that's where we've got a problem. That's where probably all of you got stuck and go, I don't know what to do. Now, this is a 4-point question. If you stop right now, you probably have 1 point. 1 point. So don't stop right there. If you get to a point you're like, dude, I don't know what. I can look at this all day long. I don't know what to do with this. Then here's what I want you to do. I want you to say, I give up. I'm making y equal to, this is 125. We'll make y equal to 30. I don't know. Make it, maybe. All right, you don't like it? Make y equal to 100. Just guess. I'm making y 100. The grader is going to be like, where the heck did the 100 come from? I have no idea where they got that 100 from. But the good news is, now that you have x and y, you can come over here and answer the question, which is what's x divided by y? 32 over 100 in simplest form. You go to your calculator and you go, okay, 32 divided by 100. Oops. Forgot to divide it by. Oops, damn, doggone it. Divided by 100 equals 8 over 25. You write 8 over 25, and if you write it like that, they have to give you 2 points. Even though you had no idea how to get this, the reason you went over here, finished the problem, simplified it, and you got 8 over 25. Now, the answer is completely wrong, but minimally, though, you got an extra point or two. So look for points like that, too, because they can really help out. Sometimes you can just make up numbers and then continue going with the problem. All right, so what we're going to do If you learned from me earlier, if you have something raised to an exponent, what you want to do is get rid of the exponent by raising it to the reciprocal. Earlier I did it with 1/3 and 3/1. So we're going to raise this to the reciprocal. But if I raise this side to the reciprocal, I got to raise this side to the reciprocal. Now the reason you do that is because these 2's cancel and these 3's cancel, and I end up with just y. Now if you type this into your calculator, 125 raised to the control division, what is it, -2/3? Oh, come on, what happened there? I think somehow got answer. I meant to hit negative. -2/3, and you get 1/25. And that's what y is equal to, 125. So now we come over here and we say, okay, we have 32/125. Now you can either grab your calculator and just divide it or whatever, and you get 800. I mean, make sure you grab your calculator. Start with control division. You take 32 over control division 1/25. 800. There's your answer. All right. That was a tough question. Uh-oh, 6-point questions. Do we have to take a break? Yes, we do. It's time to get serious. Logarithms account for a lot of the 6-point questions, but a few of them. So we got time to get serious, all right? So we're going to get serious about this. You can't solve a log question if there are 2 logs in the problem. You must condense the problem. You got to shrink it up, and you have to know the rules of logarithms to do so. The one rule of logarithms is if you have subtraction, to condense them, they condense to division. So, and that's because the log of x divided by y is equivalent to the log of x minus the log of y. That's a rule you have to know. It's one of my flashcards. But if you work backwards, that's what we're going to do. We got log of base 2. Make sure that 2's way down there, of x squared minus 7x plus 12 all over 2x minus 10 equals 3. Now I have a single log equation. Now that step you got to know. That's one you just got to get locked down. So now I have a logarithmic function. So now what I'm going to do is, in order to solve a logarithmic function, I'm going to get my inner. I got to figure out who sings that song. We got to figure out right now who sings that song. Control N. It's all about that bass. Great internet. My internet's died. It's all about that bass. It's Meghan Trainor. This train wreck sings that song, apparently, that we're going to be using. So you're going to be like, yeah, blonde girl, yeah. Whatever. It's all about that bass. I'm glad she made this song because it helps out. I should sing it to her for her. So we're going to do base of 2. My exponent is 3. These things switch sides. I know it looks really complicated, but it's the same math. Base of 2, all about the base, switch the sides. 2 cubed is equal to x squared minus 7x plus 12 all over 2x minus 10. Well, 2x cubed is really just 8 over 1. That's just 8 is equal to, now you'll see why I put it over 1 in a second. X squared minus 7x plus 12 all over 2x minus 10. So now we're going to cross multiply. This times this times this. So I get 16x minus 10 is, minus 80. Right, because I got to distribute to all that. Is equal to x squared minus 7x plus 12. So now I'm going to bring everything to the right side. I get 0 is equal to x squared minus 23x plus 92. Wow, that factoring is really going to be difficult. But I do have a calculator. By the way, I'm going to wink right now. I'll tell you why I did that in a minute. So I'm going to go menu 3, 3, 1. It's a quadratic, and my root and my exponent or my coefficients are 1, negative 23, and 92. And I click enter, enter, and I click enter. 5 point, what? Okay. Then I go back to my directions, and now you'll see why I winked. In the directions, if you had read them carefully, this was in there. Does anybody know what that says? Raise your hand if you know what that says. Okay, if you're the idiot raising your hand right now, take your hand. Never mind. Anyway, raise it nearest hundredth. You know what that means? Oh, let me read that to you. I'll translate to you. Does not factor. That's what it means. Does not factor. So, now those answers I came up with, those are actually the answers. But since I have to solve it algebraically, and this is a 6-point question, you now have to use the quadratic formula. X squared I just heard a bunch of groans. I did. I heard them right through my computer. A whole bunch of groans. Big babies. All right, quadratic formula. It is a flashcard. You need to have this memorized. A, B, C, D. A is 1. B is negative 23. C is 92. Now, if your teachers don't use D, that's fine. D is the discriminant. It's B squared minus 4AC. Now, don't put negative 23 squared in your calculator. Look what happens. Negative 23 squared, it gives you negative 59. It is not negative 529. It's really, in order to do it right, you have to do negative 23 and then squared. But if you know it's going to turn out positive, you know it's just going to be positive anyway, you might as well just square. Just don't even bother putting in the negative. So 529 minus 4 times 1 times 92. Don't look down, 161. Bama jamma! There it is, 161. So that's my discriminant. So now I have to write down the quadratic formula. And you guys got to have this locked down before that test. It's an absolute essential. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Get it locked down. Get it in your brain. It's probably going to come up. So x equals negative b is 23 over 2 times 1, which is just 2, plus or minus 161. I already did that work right there. All over 2. So now I just have to grab my calculator, and hopefully they come up the answers I got before. Control division, 23 divided by 2. You can't put a plus or minus in. You put one in at a time. Plus, control division, the square root of 161 over, daggone it, 161 over, shoot, why did that happen? 1 over 2. I think I got it typed in there right. 17.844. Now write it down. X equals 17.844288. Now I need the minus. I don't want to have to retype that in because that took me forever. So just highlight it. Go over here. Change this to a minus. Hit enter. 5.1557. X equals 5.1557. And if you look up here, when I did menu 331, those were, in fact, the answers I came up with. Now, the final answers we have to round to the hundredths place. So, 5.16, comma 17.84. Round to the hundredths place. Now, I would love to be able to check this problem. This is a 6-point problem. I got all this way down. I want to make sure I get this right. Now, here's the problem. Don't check your rounded answers. You should check your rounding to make sure you rounded correctly, but don't check your rounded problems. I'm going to put this over here. So what I'm going to do is I'm going to take this number here. It's not my rounded number. It's just the number that I came up with, I think is the answer. And I'm going to stow that in for x. And then I'm going to type in log base 2. Now, it seems like it takes a long time, but it doesn't. X squared minus 7x. X squared minus 7x plus 12. I mean, I can't tell you how important it is. This is a lot easier without plus 12, without this pen. Minus control log base 2 of, is it 2x minus 10? 2x minus 10. Now, if I did this right, it should come up 3. Or really close to 3. So now what I'm going to do is take this other one. Now, probably the other one works, but I'll take this one, stow it into x. Now, I don't have to retype that long, crazy line again. I just go up there and highlight it. Enter, enter. We get another 3. They both work. It checks, and you're good, okay? Nice job. Very nice. All right, that probably took a while. I might have to stop. I stop every couple of minutes because sometimes the voice and the audio get messed up if I don't. All right, so I'll be right back. You don't even know about it. Okay, so let's get to this quickly. Now we have 2 logs. We're going to condense them into 1 log. Now this time I have addition. Addition condenses to multiplication. So you have to know when you combine these, you're going to get log base x plus 3. Make sure you put that base way down there of 2x plus 3 times x plus 5 equals 2. Now you get your inner Megan Trainor going. I think that's her name. It's all about that base. I can't wait to see somebody tell me, yeah, we were in the gym and there's like 5 of us doing this. We're all crazy. All right, so there's all about the base, and then these 2 things, I don't care how complicated it looks like, are going to switch sides. So x plus 2 squared is equal to 2x plus 3, x plus 5. So on both sides, we're going to have to double distribute. I don't know why that's there. On both sides, we're going to have to double distribute. So x plus 2 times x plus 2, that's x squared plus 4x plus 4 is equal to, and on this side we're going to get 2x squared plus 10x plus 3x, so that's plus 13x plus 15. There's my highest positive square root, so we're going to bring everything to the right side. So 0 is equal to x squared plus 9x plus 11. I just totally messed that up because this should be 15. Oh my gosh, what did I do? Guys, I'm sorry. This is the second time I've done this, and somebody's probably going, this guy, hope he recognizes it soon because he's got his head up his keister. These should be a 3. This should be a 3. This should be a 3. This should be a 6. So what I should have here is, and I apologize for that, but I'm too tired. I'm not going to go back. You guys got it. You probably saw me doing it anyway. You're probably like, please, Krause, stop. You're an idiot. Stop. Stop. Your inner Megan Trainor messed your brain up. See, that's what happens when you sing Megan Trainor. You get all messed up. Maybe we shouldn't be doing it. It sounded like a good idea, though. So 13x plus 15. And then I'm going to bring stuff over. So I get 0 is equal to x squared plus 7x plus 6. All right, so now I'm going to factor it. X plus 1. Don't forget the equals 0. X plus 6. So my 2 answers are x equals negative 1. And x equals negative 6. You must check both of these. Don't just check one of them. You must check both of them. They don't take that long to do. It's too much stuff on my screen. So we're going to do negative 1 control var x. If it's a 6-point question and it doesn't have that long quadratic formula and all that crap, there's probably a really good idea that one of these is not going to work. So log base control log base x plus 3 of 2x plus 3, 2x plus 3, plus control log x plus 3 of x plus 5, and somehow we missed the x down here, x plus 5. And I hit enter, I get 2. Oh. That's what I want it to be equal to. So far, negative 1 works. Now we're going to try negative 6. Negative 6, control var x, enter, and just hit this up arrow. Oh, non-real calculation doesn't work. So the only acceptable answer is negative 1. Now the reason it didn't work, just so you know, is because we're trying to put a negative 6 into here, which would make your base negative, and you can't have a negative base. All right, here we go. Another 6-point question. Remember what I said earlier. If the bases are not the same, you're going to try to make them the same, and you want to use 3, 2, 3, 5, and every once in a great while 7. You'll use 2 if it's even. You'll use 5 if there's a 5 in the problem, and if it's odd, you use 3. So we're going to use 3 here. So 81 is 3 to the 4th. If you don't believe me, just try it on your calculator. But I still have x cubed plus 2x squared. 27 is 2 cubed. 27 is 3 cubed. But it already had a 5x over 3. Now that the bases are the same, all I got to do is set the exponents equal to each other. So the right exponent is 4x cubed plus 8x squared. And here the 3's actually cancel, so I get just equal to 5x. Okay. So I'm bringing everything to the right side, left side. 4x cubed plus 8x squared minus 5x equals 0. And now we got a factor. So I take out an x, and I'm left with 4x squared plus 8x minus 5. Now I got to factor that behemoth. Now, if you don't want to factor it, what I could do is at this point right here, I can tell you what all the answers are. I'll just type that in. So I go menu, 3, 3, 1. It's a cubic, though, not a third degree. Or it's not a fourth degree. It's a 2 degree. It's a fourth degree. So we're going to go 4, 8, negative 5. 4, 8, negative 5. But notice it's looking for the plain old number without an x, and so we have to put a 0 in. It's a placeholder, 0. My answers are 0, negative 5 over 2, and 1/2. Well, I know this is 0. So this one's got to be x equals negative 5 over 2. And this one is x equals 1/2. Oh. Well, if this was just x equals negative 5, this would be x equals positive 5. Oops, excuse me. This would be x plus 5. But I got to put a 2 out front because I got to get 4x anyway. And this one needs a 2x out front. And if it's positive 1, it's negative 1 here. So if you want to work backwards from factoring using this calculator, you certainly can do so if you have it. All right, I should check these answers, but it's getting late. They all work. They're all fine. And I have to take a break before you even think about doing this problem. So let me tell you a story. There once was a guy who thought he was an English teacher. And then he decided to write math problems. And look what happened. It's either that or some crazy chemistry teacher or earth science teacher or whatever got into the math room by mistake and said, you know what? Let's throw a natural logarithm, really difficult looking paragraph at the kids, and they'll get all confused and get all flustered and they won't be able to solve it. And the answers come out kind of freaky deaky anyway, so I don't even know if you got the right answer. Boy, this was a tough problem. This was a behemoth of a problem, and most of the kids did not do very well, but we're going to rock and roll on it. So let's see what we got here. It says the temperature T of a given cup. Oh, I hate when it does that. All right, so the temperature T of a given cup of coffee, hot chocolate, coffee, you got coffee to made, for T minutes can be modeled by this function. Now, T0 is the temperature of the room. And in this case, T0 is going to be 68 degrees. So whenever we do this problem, T0 will be 68 to T's. And T is the temperature of the hot chocolate. So the question says, if the hot chocolate is 150 degrees after 3 minutes, find K. That's what we're going to do first. So I'm going to plug the numbers in down over here. We're going to do natural log of T, which is the temperature of the hot chocolate, 150, minus the temperature of the room, 68, is equal to negative K, we don't know what that is, times 3 plus 4.718. Now, where in the hell did that problem come from? But then you're like, okay, wait, let me just tackle this. This is really just the natural log of, was that 82? I don't even know. I'm so tired, I don't even know. I think it's 82. 150 minus 68. 82. So this is really just a negative, then this is really just negative 3K plus 4.718. So Now I'm going to take the 4.718. So the natural log of 82 minus 4.718 equals negative 3k. Divide by negative 3, divide by negative 3, and I'm going to get k equal to that freaking mess. So control division, the natural log of 82 minus 4.718 all over negative 3. 0.10.103.760. So where did it tell us to round to? Rounded answer to the nearest thousands place. So that's 3 decimals. So now I got k equal to 0.103. And that really wasn't that hard. I didn't have to use different forms. I didn't have to change different forms. That really wasn't that bad. So I got one. Now this is a 6-point question. I'm probably about halfway through. That I got k. Hardest part of this problem is reading it. So using this value of k, find the temperature T. So we're going to look for T of this hot coffee if it has been sitting in a room for 10 minutes. So now we're going to use this equation, natural log of T minus 68 is equal to negative 3. Nope. It's what's the formula again? Negative k. So negative 0.104 times 10 plus 4.718. So this is all just numbers. So I'll just type that in. 0.104. Oops, I forgot the negative. That makes a huge difference. Negative 0.104 times 10 plus 4.718 equals 3.68678. So the natural log of T minus 68 equals 3.678. 3.678. All right, so now here comes where the hard part. I now have a logarithmic function that I need to solve. And in order to solve it, I need to use exponential functions. So I'm going to turn this into an exponential function. But with natural logs, you have to use e. Boy, I don't even know if that's my big head's behind that. Sorry about that. So all I did was clean this up. So I need to do e. And then these two things are going to change sides. So e to the 3.678 is equal to t minus 68. I'll add 68. And I get t equals. So I come back with my calculator. I go e to that plus 68. 107.567. T equals 107.567. Rounded to the nearest degree. T equals 108 degrees. I hope that's the right answer. I think it is. All right, that's it. Woo, that was an ugly problem. 2 problems left, my bros and oh, I almost said my bros and hoes. Ooh, I did say it. Ooh, that's not good. Anyway, all right, let's do this. This one's not bad. So it's all about that base, inner Megan trainer. We're going to do, come on, you piece of garbage, stop messing with me. We're going to write x plus 3, which is our base, x plus 3. These two sides, switch, squared, equals x cubed plus x minus 2 all over x. Now this thing cubed, squared, I think I can get this right. X squared plus 6x plus 9. Now if you don't like that, write it out twice. I don't want to waste any more time. X cubed plus x minus 2 all over x. This goes over 1. Now we're going to cross multiply. X times this is x cubed. Wait. X times this is all over 1. X times this is x cubed plus 6x squared plus 9x equals 1 times this. X cubed plus x minus 2. Now, because I got an x cubed on both sides, they kind of just cancel each other out. So here's my squared term. So I want everything coming to the left side. So I get 6x squared plus 8x plus 2 equals 0. I'll take out the common factor of 2, so it's a less factoring. 3x squared plus 4x plus 1. There's only one way to multiply to 1, and that's a plus 1 and a plus 1. And there's only one way to get 3x squared. It's that. So my two answers are x equals negative 1/3 and x equals negative 1. Now, since this is a 6-point question, there's like a 90% chance that one of these does not work, especially this one wasn't that bad of a problem. So there's probably a really good chance that one of these does not work. So let's try them. Negative 1 divided by 3, control var x. Press enter, press enter. Oh, I forgot the x. X, press enter. Oh my God. Negative 1 divided by 3, control var x. Enter. All right. So now I got to type this in. Log base x plus 3 of fraction control division x cubed x cubed. Oh my gosh. So hard to do on this thing here. So x cubed plus x minus 2 all over x. Enter. 2. That's what we want. 2. Perfect. All right. So now we're going to try negative 1. So negative 1, control var x. Always doing the first check is hard. On the second check, come up here. Enter. Enter. Oh, they both work. That's weird. Normally they don't work. So you have to check them though, because normally they both don't work. Negative 1/3 and negative 1. All right, so this last problem that's on here is actually from this year's Common Core test, but it is a logarithmic question, so I wanted to add it in as well, because who knows, they may put something like this on this year's, and those who did not know how to do this problem, I want to make sure you know how to do this problem. Since it's a long problem, let's see if I got time. So drugs break down in a body at different rates. They tell you that the formula is going to be this, where n of t is the amount left in the body. N0 is the original dosage, R is the decay rate, and t is the time in hours. And the first thing they wanted you to do is just write the equation. So I have to write A of t is equal to, the starting amount for A is 800 milligrams, e to the negative. Now, what was my rate? That was my rate, 0.347. 0.347 t. So there's my first equation. B of t is pretty much the same. 400 e to the negative 0.231 to the t. All right, so I think you got 1 point for getting that. Now all we got to do is put these things on this graph here. So let me shrink this up a little bit. So the first thing I'm going to do is put these suckers in my calculator just to kind of get an idea what they look like. So I'll go to calculator mode, graphing mode. There's already something in there. I don't want it. Graphing mode. All right, so I'm going to do 800 e to the negative 347 x. I got to use x because that's what the function uses. Okay, let's press tab. I can't see that one. I don't know what happened. Maybe I typed it in wrong. 400 e to the negative 0.231 x. Huh. Well, if you ever can't find your graphs, the easiest way to do this, and you can do the same thing on the TA4, you go to Menu, Windows, Zoom, and there's a Zoom Fit feature. Just click on Zoom Fit. Oh, wait a second now. Now I can see them. We only want the positives anyway. So it's going to kind of look like this. Oh, I don't like that. So anyway, I got this only going out to 5. And looks like my y-intercepts are somewhere around. Let me go look at where my y-intercepts are. Control T. My y-intercepts are 0. Whoa, stop. I'm not even doing anything. Okay, Control T. All right. It looks as if my y-intercepts are 0, 800, and 0, 400. So if I go into menu, now that I can kind of see them. Oops, Control T, escape. Control T, get rid of that. I'm going to go into menu, and I'm going to change the window settings. So I'm going to change my window settings, and I know I want this to be like negative, I don't know, -2. And this will be like 20. I'm not sure how far it'll go. And this is going to be like -50 because I know I have to get up to 800. So I'm going to make this 1,000. Oh, that's what they look like. Oh, now they look like exponential functions. Now I know what I can see where they hit and cross. So now I know I can go to my table and I say, okay, you'll go to your table, you go Control T, and blue, we're going to do 0, 800. God bless it. Stop. 0, 800. So 1, 2, 3, 4. Why do you keep backing on there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 400. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 800. Perfect. And if I look at my graph, hopefully it's not doing, still doing crazy stupid stuff. Control T. I don't know why it's doing that. Looks like I only have to get out to maybe 10. Because earlier I want to find out probably right here is where they cross. So let's go just to 10. So 0, 10. And this will be 5, so in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm guessing 10. 1, 2, 3, 4, 5, 6, 7, 8. I think I got off by 1. This is 5 right here. All right, 5. All right. And then, so I know, let's do the 800 point. There's a point at 800. What is it at control? Let's see if I can go back to that table. I'm not clicking on anything. Control T. So at 1, the blue one is 565. So that's 400. That's 600. So it's about halfway between at 1. And at 2, it's about 400. And at 3, it's about 300. Let's see. That's 200. So it's at 3, it's about 300. Somewhere in the middle here. God, geez, I hate that when it does that. And at 4, it's at 200. And at 5, please don't do anything crazy. Let me just do it this way. At 5, it's at 140, so this is about 100. At 5, it'd be about 140. Not sure I'm doing this right. Anyway, in order to save time, I know it's going to do this. And then I get my other color out. I do blue. I'm going to do the same thing, and it comes through like this. And you'll plot the points that you can plot. Do the best job you can with that. That's what you should have done. Well, then the next question says, and it didn't say you could solve it. It didn't say you had to solve this algebraically. The next question says is, to the nearest hour t, when do the amount of the given drugs in patient B begin to exceed the amount of patient A? So you really, what they're asking you is for, find the point of intersection. So if you just go back to your graph, get out of table mode, and you just go menu, analyze the graph, intersection 4, and you just click boom. Oh, I forgot it doesn't like that. Click, click. It tells you that the intersection, I'm not sure why those are rounded. Those shouldn't be rounded. But anyway, this intersection is 5.98 hours. So you say approximately, get away from me, Cortana. X equals about 5.98 hours. So X equals 6 hours. Second part was a little tougher. You could have done it two ways. You want to find out when there's 15% of the drug left in the system. So first thing I do is figure out what that number is. You take 800, multiply it by 0.15. Notice it's bigger than 10 this time, so it's bigger than it's 0.1, not 0.0. And you get 120. So you could take the a of t function. So you take 120 is equal to 800 e to the negative 0.347 t. Divide by 800. Get the weird thing alone. And you get 0.15 is equal to e to the negative 0.347 t. Now we've got to do the natural log of both sides. So the natural log of e, the base, e, now of 0.15 is equal to negative 0.347 t. Divide by negative 3.47 t, or just negative 3.47. So now I take, go to my calculator, I go natural, escape. Natural log of 0.15 divided by negative 0.347. And I get 5.467. So 5.467 is equal to t. It said round to the nearest tenths, so t is equal to 5.5. Now, having said that, I could have done this graphically. If I go back and look at my graph, if I go back and look to see what my graph looks like, I could do this graphically very simply. All I got to do is hit tab, graph the line 120, tab, graph the line 120. All right, there it is. And I want to find out when that intersects with blue. So I want to get rid of the red function. So I'm going to hit tab. I'm going to get rid of this one. Uncheck it. And click enter. Uncheck it. And I want to find the point of intersection of these. So I'll go into menu, analyze the graph, intersection, click, click, and there it is, 5.47, which is 5.5 hours. Okay, kids, that's it. Woo! Man, that was rough. Hit subscribe, hit like, hit thumbs up. Tell me how much you has thoroughly enjoyed this incredibly long video and having to suffer through my craziness of this video. But I hope you enjoyed it. Oh, we're winding down, kids. The kids that don't go to summer school, the kids that don't sit in that hot gym out there having fun, fishing, boating, hanging out with their homies, doing whatever you do, man. Do whatever you do. Are the ones that work their butts off for the next 2 weeks. Study my flashcards. Work your butts off. You're going to enjoy your summer. Or you might have me in summer school. It's been known to happen. All right, kids. Catch you on the fly side, flippies. Goodbye and good night. Bye, that was a long video.